Okay, so for this lesson in category 1, we're going to review laws of exponents. So remember, you have two things that you have to remember with your laws of exponents. You have the order of the laws that you have to work, but you also have to remember what operation you are going to perform on the exponents. So we're going to start with the power law, and you multiply. Then you move to the law of multiplication, where you are adding the exponents. Then you take care of your quotient law, which means you're going to subtract the exponents. You will take care of any zero or negative exponents at the end when you are cleaning up for your final answer. So remember, to take care of a zero exponent, you simply cover the base and the zero exponent with a times 1. And then if you have a negative exponent, you're going to make a fraction and move to the other side. And then we're going to talk about this. This is just how to rewrite an expression when your exponent is a fraction. So this is going to kind of be taking place when you have zero negative exponents. You wait till the very end to deal with any fraction exponents. So now we're going to look here at our first example. We are going to simplify the expression 3 times x to the 1/2 times 4 times x to the 1/3. So I see parentheses, so I'm thinking power law, but what I'm missing is I'm missing an exponent out here. So what I really have is just multiplication. I am just multiplying 3 times x to the 1/2 power times 4 times x to the 1/3 power. So what I'm going to do is, first thing I'm going to do is I'm going to pretend that my variables aren't there. My x's are gone. What would be the math problem I would have? I would have 3 times 4, and 3 times 4 is 12. And so now I'm going to take care of my next base. And see, I know I have multiplication law here because, look, I have one base of x here and one base of x here, and they're being multiplied. And I want to be able to write a single base of x in my final answer. So what I'm going to do now is I'm going to take this exponent and this exponent, and I'm going to multiply them. Well, when you multiply fractions, you multiply numerators first, so that would be a 1, and then you multiply denominators. 2 times 3 is 6. So I've got 12 times x to the 1/6 power. So now we're going to revisit this because I want to show you another way you can write x to the 1/6 power. So what we're going to do is, up here, notice I have an n in the denominator. So whatever number is in your denominator now becomes your new index. So whatever your denominator is, it's going to become an index, okay? And then you're going to put a square root, and then notice our bases are the same, okay? So whatever base I had here is going to remain the same base, but this time it's just going to go inside the square root. Okay, and so now I'm going to take care of the numerator, the top part of my fraction exponent. And that m is going to go inside the square root symbol with the x, and it's going to become the exponent. So I'm going to have x to the whatever power the numerator is, and then I'm going to have a square root around all of that, and then my index is going to come from my denominator. So let's see if we can follow that pattern and apply it to what we have here. Okay, so I'm going to start off with a square root. Now, I want to write my base. What is the base that has the exponent as a fraction? That would be the x. Okay. And I need to write a power here. And look, it's coming from the top of my fraction. So what number is in the numerator of the fraction? That would be the 1. Okay. And then the index is going to come from the denominator of that fraction exponent. So what number was in the denominator? The 6? Okay, that 6, that becomes your new index. All right, and now you're going to ask yourself, well, Miss Love, what do we do with that 12? Well, the 12 was not being raised to the 1/6 power, only x's, so the 12 is not going to go inside the square root. So the only place left for that 12 to go is it's going to have to be outside the square root and being multiplied. So these are saying the same answers, they're just written two different ways. So I want to just touch on that in case they show you that in a test or a quiz. All right, so let's look at example 2. Again, we're working our laws of exponents here. So I do not see any parentheses with a power outside the parentheses, so no power law. Now I'm going to look for multiplication, and I'm going to look here in the top of my fraction. I want to see, do I have a multiple base of x, a multiple base of y, or z just in the numerator? And I do not. So now I'm going to check, do I have multiple bases in the denominator? And I only see one base of x and one base of z. So those are single bases in the denominator. So we do not have the multiplication law. Now we're going to move to quotient. And I see I have a quotient law because I see a big fraction sign, which means divide. So now what we're going to do is, if I pretended all of these variables were gone, what would be the math problem I would have? I would have 5 divided by 10, which is 1/2. 1/2. I'll make that one a little bit bigger. All right, and so now I'm going to look at my bases. Okay, so I have a base of x in the numerator and a base of y, a base of x in the denominator. So now I've got to subtract the exponent. So in my calculator, I'm going to do 3 minus a negative 2, which is going to be 5 because that's going to turn to addition, and 3 plus 2 is 5. So it's going to be x to the 5th power. And now I'm going to look for my next base. Okay, so I have a base of y in the numerator, but I don't have any y's in the denominator, so I'm going to treat it like y to the power of 0, like I have 0 y's in the denominator. So I'm going to do negative 2 minus 0 in my calculator. Well, if I start with negative 2 and I'm taking away nothing, I'm still going to be left with negative 2. And so I have y to the negative 2 power. So that didn't change because I wasn't subtracting anything from that exponent. All right, so next I'm going to have z. Well, I see that I have a z in the numerator and a z in the denominator, but the thing is, I don't have an exponent here. So if you are missing an exponent, it is always going to be an invisible 1. Okay, because if it was 0, that z wouldn't be there. So in my calculator, I'm going to say top exponent 1 minus the bottom exponent, which is 2, and now I'm going to be left with 1 minus 2 is negative 1. So now I'm going to have z to the negative 1 power. And now if you notice, I've gotten rid of my fraction bar through using the law of quotients. Okay, so I've taken care of that. Now I need to clean up for my final answer. So I want to check, do I have any 0 exponents? I do not. Do I have any negative exponents? Yes, I do. So what I want to do is I want to make a fraction. And now I need to start placing things in the numerator and the denominator. So I'm going to start with my number first because that's easiest. All right, so the 1 is going to stay in the numerator, and the 2 is going to move to the denominator because they have to stay where they are in that fraction. Okay? And so now I'm going to look for any negative exponents. Well, I see y has a negative exponent, so I got to make a fraction, which I did, and now I'm going to move it to the other side. So it's going to move to the denominator, and when it does, that 2 is going to become a positive exponent. And it's got to become positive, or moving it to the bottom of the fraction doesn't do anything and makes no sense. So that's why we're moving it. And now look at z. Z also has a negative exponent. So we're going to do the same thing. We're going to move it to the other side of the fraction to join that y squared. And then that negative one is going to change to a positive one. But remember, when you're looking for this on a quiz or a test, they're not going to show you that power of 1. It's just going to be z. Okay? And so now I need to fix everything else. Well, I need to take care of my x to the 5th. And since this exponent is positive, it's got to stay in the numerator where it is. It doesn't want to move. It's already positive. It has no reason to move to the denominator. So this is going to be your final answer. It's going to be x to the 5th. Remember, you won't see that 1 in your final answer. So it's just going to look like x to the 5th, all divided by the products of 2, y squared, and z. That would be your final answer. All right, looking at example 3, we have x to the 3rd being raised to the power of 3. So I'm going to start again at the beginning of my order of operations for laws of exponents. I've got to look for power rule. And I have a power rule right here. And remember, when you're power rule, you are multiplying your exponents. So we've got to multiply 1/3 times 3. So that's going to give me x 1/3 of 3. So if I took 3 wholes and split them into thirds, I would end up with a whole. So I would end up with x to the 1. And then, or I could just write it as x. That would be my final answer. And I don't have any multiplication laws because I only have one single base of x. I don't have a quotient law. I don't see a fraction. I don't have any 0 negative exponents. And I don't have a fraction exponent that I can rewrite using a square root. So now let's look at example 4, a word problem. A square has a side length of 5x squared y. The area of the square can be found by using a equals s squared. What is the area of the square? Okay, if they're telling you area, that is a keyword for multiply. So we are going to be using the multiplication law. So let's think about it. Let's go ahead and draw a picture. I've got a sketch of a square, and it tells me that the side length is 5x squared y. Okay? Well, if I want to find the area, I've got to multiply length times width, and the thing about a square is, I know from experience, is that the length and the width of the square are the same size, same length, same distance. So if I want to find the area, all I have to do is multiply the length of the square times itself, 5x squared y. So I'm going to go ahead and multiply. I'm going to pretend like these letters aren't here, and I'm going to multiply my numbers, and I'm going to get 5 times 5, which is 25. And now I'm going to look at my next base. See, I have multiple bases of x, and I want to write it as a single base of x. So I'm going to say I'm going to add my exponents because that's what I have to do when I'm using the law of multiplication. So I'm going to say, okay, I've got 2 here, and I'm adding another 2 here for a total of 4, so it's going to be x to the 4th power. And now I'm going to do the same thing with my y's. I've got one base of y here, and I've got one base of y here. Remember, they're not zeros. If they were zeros, those y's would not be visible, so it's 1. So I'm going to add 1 plus 1, which is going to give me a total of 2. So my area for this square is going to be the products of 25 times the value of x to the 4th times the value of y squared. And that's going to give me my total area for this square.